Our final speaker for this session today is Dr. Chris Kubert, who is the team leader for the Basin Prospectivity team. So Chris has come from the University of Adelaide with a PhD in diagenesis and sedimentology, but has more than 25 years of industry experience in reservoir and regional geology, working in basins worldwide. So in 2021, Chris joined Geoscience Australia's offshore Otway team as a senior basin analyst, and in early 2023 started with South Australia's Department for Energy and Mining as the team leader for the Basin Prospectivity, which includes the search for natural hydrogen. So please join me in welcome Chris.
Thank you very much for that introduction, Anna. Yes, so my background's oil and gas. And prospectivity is something that's really close to my heart, having come from industry, consulting. So what I'm going to show you this morning is a bit of a snapshot of natural hydrogen in this state. And it's really quite exciting, very new. And I suppose is the crossover between petroleum and the mineral sector. So a really nice thing to round out this morning. I'll go through a bit of context. I'll give you a bit of legislative framework. I'm not going to get too heavy on that. I might sort of skip by a little bit. If you want more information, obviously it's all on our website. I'll talk a bit about prospectivity in South Australia, and then we'll go into an update of what's actually happening in the exploration space. And so before I get too much further, this map here, you'll see this map pop up a few times in my prezzo this morning. This is actually the map of hydrogen exploration application areas in the state, coloured by company. And what I'm going to focus on later in my talk is here in the solid colour. This is the Ramsay 1 and 2 exploration area on Yorke Peninsula. And we have another exploration area here on the Eastern Eyre. Okay. So for folks, I'm going to give you the answer up front. So if folks don't want to see the detail, after this slide, now is the time to leave. So the experience with hydrogen exploration in South Australia so far has shown that if you have the right regulation in place, if you have the right rocks, if you have a proactive government, and also an entrepreneurial industry space, then the possibility of exploring for natural hydrogen is real. And that just sounds like a bunch of words, right? But this is not happening in many other places in the world. South Australia is unique to a degree in this aspect. I think the entrepreneurial industry is a major factor in the success so far of exploration for hydrogen in this state. But a bit of context. So why are we doing this? Why are we looking for hydrogen? And the answer is pretty simple. This is the Open NEM website. This is the Australian Energy Market Operator data. And you can see in yellow is solar. This is from South Australia, sometime in February. Green is wind, gas, natural gas, methane is here in orange, and coal is in the purple there. So clearly we can see the diurnal aspect of our nature, our energy grid going up and down. The solar and the wind is happening during the day. And at night, as you can see, we need gas and we need coal. This bright blue here is our batteries. That's what our batteries do every night and every morning. As we use less gas, or gas is decreasing over the years, we need something to replace the natural gas. So in comes hydrogen. The idea is we can blend the hydrogen in with the methane. This is to keep our lights on at night, but also it's to feed our industry and the idea of green iron mining in this state, underpinned by the energy from natural gas and hopefully hydrogen. Today I'm only going to talk about natural hydrogen, not manufactured hydrogen, until we get to the end. All right, very famous map. You'll see this map if you go to any natural hydrogen talk in this country, you'll see this map at some point. This is from Chris Borum in 2021 from Geoscience Australia. Essentially, global researchers Zagonic, Moretti did a worldwide search, and Australia had a number of occurrences of natural hydrogen. And we're going to focus on South Australia here. Chris Borum dug a little deeper. Chris is a famous geochemist on the petroleum side of things. He and his team have dug deeper and had a look across Australia. And indeed, after this research by Zagonic, Moretti, Chris Borum and others, particularly the first two, the Government of South Australia and the Department in general basically reformed the petroleum exploration laws to allow hydrogen to be explored for. This is really slick. This was really key. This enabled a new industry to start, and that entrepreneurial spirit of that players in this industry put two and two together, and they nominated a number of blocks, and you can see here in the pink here. To say this enabled a flurry of activity is an understatement. We've had 40 applications since 2021. What other types of licences? As I said, I won't get too heavy into this, but essentially it's the petroleum exploration licences, petroleum retention licences, and the petroleum production licence amended, so now you can explore for and produce, and as of April this year, you can also transport hydrogen, helium, and the products of those gases. This is really key. This has really enabled a new industry. But why South Australia? You know, why this reform? Why this new industry? Well, I think part of it is because South Australia has always had a government sector that is into innovation. We've always had the ability in South Australia to look into free public databases. As in my introduction, I've worked around the world. A free public database is also unique, not just to South Australia, but to Australia. Globally, this is a unique situation, and we can see here, maybe not up the back, but the Robe 1 well in 1915, 25.4% hydrogen, 1921, American Beach 1 on Kangaroo Island, 60 to 80% hydrogen, and 31, the Ramsay oil bore on York Peninsula, 51 to 68% hydrogen, tested by the government chemists at the time. This was found in our database, this result, and it was then acted on by companies like Gold Hydrogen. Here we are on the York Peninsula, and we can see here a number of these salt lakes. Early ideas and understanding is that maybe these salt lakes are related to seeping hydrogen. Our Ramsay oil bore sits about here, 1931. I think what's fascinating is that the play mapping approach that we use in the oil and gas industry, when you'll see Sharon Tianen and Paul Strong use this approach later on today, the hydrogen industry, the exploration for natural hydrogen, is using the same concept. So breaking up the geology of hydrogen into its play elements. So a source rock, a seal, a reservoir. Now, in the oil and gas space, these are, I wouldn't say simple, they're not simple, but there's less variety, I would say, than in the hydrogen exploration game. Particularly, I would say, on the source rocks. So South Australia, as far as prospectivity goes, we are very well endowed. We have basins that show hydrocarbon shows. I've just seen that, I've shown you that. Ramsay, Robe 1 in the Otway Basin down here. And interestingly enough, Chris Boreham, again, when he did his review in 2023, also showed the Cooper Basin. So this is the gas basin up here that supplied South Australia with energy for the last 60 years. In this part of the Cooper here, Chris Boreham suggests there might be natural hydrogen in the Nappamerri Trough. We also have our provinces, of course. So our mafic and ultramafic rocks in abundance, iron-rich, uraniferous rocks that are also possible source rocks for hydrogen. When we put this together, we have to ask ourselves the question, and in Australia, in South Australia, in the Nappamerri Trough, have we missed something? Is a reasonable question to ask, have we missed hydrogen? Is this something real? And we've drilled 2,500 wells in the Cooper Basin where we're looking for gas. 20,000 wells in the oil and gas industry in Australia where we're looking for gas. Why have we only seen a handful of hydrogen shows in the whole country? A handful, less than a handful in South Australia. One of the answers to that question possibly is we weren't looking for hydrogen. We were looking for methane. We were looking for H2S. H2S can be a common gas associated with oil and gas drilling, very dangerous. Maybe we just weren't looking. The rest, as they say, is history. Buru, 2H Resources, in their Canning Basin wells up here, in the recent years, actually put hydrogen sniffers on these oil and gas wells and did find hydrogen. So maybe this is the case. We just haven't seen the hydrogen because we weren't looking. We are looking now, though. We are definitely looking now. Because as I said, we have this decline of natural gas, and we need to find a replacement for that hole. Our consumption is increasing and our supply is decreasing. Enter hydrogen, enter our explorers, and let me just concentrate on gold hydrogen here in the gold colour. Do you like that? On Yorke Peninsula. So gold hydrogen, as I said, the companies are using a play-based process of exploration. So taking a huge area and narrowing it down, looking at individual play elements, the source rock for hydrogen, the seals, the traps, the structure, and the reservoir. And let me also show you they're doing what we call dry hole analysis. So looking at water bores and other wells around these Ramsay 1 and 2, bores in the 30s, drilled in the 30s, and looking for other evidence of hydrogen and helium. This is very good exploration practice in oil and gas space, and it's been transferred to the hydrogen exploration space. You're going to see some logs now. So we're looking at the Stansbury Basin here on Yorke Peninsula, early Cambrian sequence, the Parara limestone and Kulpara limestone and dolomite. We will see that these are our reservoirs. And here we are. So we have Ramsay 1, Ramsay 2. These were drilled within a few hundred metres of the 1931 well. And as an old explorer, they found hydrogen, they found helium, so they have proven the play. Not commerciality, they've proven the play. They've proven that this location, the Ramsay location, is a hydrogen and helium area. So I'll concentrate on Ramsay 2, but the Ramsay 1 result here for folks, this is our gamma ray here. So we have our mud there, we have our limestone and sands here, dolomites and so on. We'll look at the Ramsay 2. I think this is roughly 1,000 metres here, something like this. This is from the Gold Hydrogen website. You can all have a look at this online on their website. And here is the result. Now I think this is a fascinating result, Ramsay 2. So density, sonic, we can see our hydrogen's very specific here in the Parara limestone, and you can see our helium is actually distributed through the Coolparra, a little bit in the Parara and down the hole. This result is being commercially evaluated right now with seismic being shot at this point in time. And you can see here, these are all the seismic lines that have been shot by Gold with the seismic trucks there. This is also the drilling rig for the Ramsay 2. So this company has basically had a discovery and that's now looking at appraising that discovery and understanding its commerciality. This is a really interesting result for South Australia. Great result for the company, hopefully, but also bodes well for this new hydrogen industry in our state. So that's a bit of an update on the exploration for hydrogen. But I thought I'd finish up this morning and just show you another really interesting aspect. Now, this is on the manufactured hydrogen side of things, where we have, gas storage. So I don't know if people are aware in this room, but we are currently, as a state, we are currently storing 1.7 million tonnes of CO2, or will do by the end of the next calendar year, at Moomba. So that's CO2 being produced in the Cooper Basin, being sequestered into depleted gas fields. So this is gas storage. Now we are storing CO2, and this is one of the world's largest CO2 gas storage projects in the world here in South Australia. But we can not just only store carbon dioxide, we can also store methane, which is obviously happens a lot in Europe, and there is the possibility of storing hydrogen. Now, the reason why we would do this, because transporting hydrogen is not the easiest thing. So if you can produce and store your hydrogen in the same location and locate industry around, this is an advantage. So our gas storage legislation or framework, tenement framework, is the same as for petroleum. Again, we have just used the petroleum and legislation and brought in the regulated substances of hydrogen and helium. So this is a piece of work project by Entex in the Polder Basin. So here we are, Eyre Peninsula, Western Eyre Peninsula, Polder Basin here, Neoproterozoic to Permian. We actually have, in the 80s, oil wells here drilled offshore, just offshore. Mercury 1 in particular intersected a huge column of salt. So the idea here is to dissolve the salt, make a cavern, and store manufactured hydrogen. And the work from GA, Andrew Feitz in GA, has shown this, and this modelling is occurring. So, to finish up, yeah, really interesting on the hydrogen in this state. Manufactured and storage, natural hydrogen exploration. And I think it's the natural hydrogen exploration that has probably piqued the interests of people. And I think we can conclude the following so far. It's still very early days for natural hydrogen exploration in this state and in the world. But the South Australian experience has shown that if you have a regulatory, licensing and investment framework in place, there are entrepreneurial members in industry, that culture of maybe risk, of taking on risk, of doing something new, of trying to think outside what is normal, access to historical data. This wouldn't have occurred in South Australia if these small companies didn't have access to the public data set. And of course, you have to have the right rocks. You have to have the right rocks. You've got to have these. And South Australia has these in abundance in our basins and in our provinces. So as a final statement, this has been our experience in South Australia so far with natural hydrogen. It's not an overstatement to say that folks here in South Australia, in Australia and globally are looking at South Australia and what happens next. I was talking in Tokyo to a room of 400 people about this very topic. There's a lot of interest in the world and Southeast Asia on this topic. So we're all looking forward to what comes next in the activity of hydrogen exploration, and we will be seeing different plays tested in the next few years. So really looking forward to it. That's all from me, but big thanks to Eleanor Alexander, who's in the room. Eleanor has done so much of the work here, was involved in this space, this change of regulation. Also Dom Pepicelli, I'm not sure if Dom's in the room, Dom as well. Mario and Bettina Bendel, all major contributors to the understanding of this on the government side. So many thanks for your attention this morning. Hopefully I haven't taken too much time away from a coffee. There you go.